Hi everyone, today we're going to be going over motion and speed. What you're going to need for this lesson is going to be your science notebook. Here's the cover right here if you need a hand. Get ready to open to page 6. You'll need a pencil, a highlighter, and a calculator too, because a little bit later we're actually going to do a pretty fun lab. Okay, so my first question that I'd like you to think about for this lesson is how are distance, time, and speed related? So take a moment to think about that. It might not be as complicated as you think. If you think about it, if you're trying to figure out the speed of, let's say, a car, if you've been in a car before, you might recognize signs that say MPH, which stands for miles per hour. And what that's telling you basically is a distance of a mile, that's a pretty far distance, and a time that it takes you to travel that mile. And then it tells you a speed, which is your MPH, your miles per hour, or your speed limit. So that might be a pretty tricky comparison since I know none of us are driving yet. But if you think next time in your car, go ahead and look for those signs and you'll start to realize that those are telling you a speed for miles per hour. Now, how can you describe the location of an object? Friends, this is going to be on page 6. If you're not already there, make sure you're open and have your highlighter ready because we're about to highlight some definitions to help us describe the location of an object. So the first thing you might need when you're describing a location is a position. Now, highlight this in your textbook, this sentence right here. It says, position describes the location of an object. Often you describe where something is by comparing its position with where you currently are. That's a very important point for when we're describing the location. But there's one more thing before I ask you a question about this. You're also going to need a reference point. Now highlight this sentence too. A reference point is a location to which you compare the other locations. So for example, if I were to ask someone where the garbage can in the classroom is, they're going to think of some reference points like it's to the right of Miss Kreeb's desk or something like that. So my question is, for our think moment, how can I describe where I am using position and a reference point? So take a moment, look around you, think of some reference points so that if someone were to ask, where are you? You can say your position and some reference points to describe your location. Next up, what is motion? Now friends, we're on page 8. Highlight this sentence in your textbook. It says, motion is a change in position over time. A change in position is evidence that motion has happened. So if you just think of this basically, motion, movement, what's basically happening is an object or a person or a thing is changing where they are over a certain amount of time, just like this definition says. Now look over here at this image right here and think. Does this image show motion? Why? Now let's use our scientific language that we've learned so far to explain. If you answered yes, that this does show motion, you would be right. And that is because, as we can see, this person on a bike is traveling and changing position over a certain amount of time. We could see she's starting up here and then moving down here, or even further, I guess, to show this change in position over time. Next up, friends, we have how is distance measured on page 8. Now, in order to figure out how is distance measured, we have to first think, well, what kind of distance are we looking for? So go ahead and highlight these points too. First one says we can measure straight line distance between two positions. This is also called the displacement. Now, I'll come back to this in 1 second, but first let's look at number 2, which says total length of a certain path between those positions. So if I'm trying to get from point A to point B, and my path goes all the way up here and down and up again and back down, we can measure that total length of this path. Or we could say, well, maybe there's a shortcut that goes just right through this straight line, which is called the displacement. Now, friends, as you can see down here, it says, during our lab today, we will be using straight line distances. We'll come back to that later. Now we have speed and average speed on page 9. Now speed, let's highlight this again. The speed of an object is a measure of how far something moves in a given amount of time. Speed measures how quickly or how slowly the object changes position. So just like we learned how motion is a change in position over time, the speed is saying, well, how quickly does that object move in that given amount of time? Now we can also take a look at average speed. Now we're really going to need this for our lab today. Average speed, highlight this in your textbook, is a way to calculate the speed of an object that may not always be moving at a constant speed. So sometimes an object might actually move at a certain speed during its whole path, but other times things might be inconsistent or change their speed as they're moving. You can kind of think of if you're on a bike, you might start moving a little bit slower and then you can move really fast and then you might move a little bit slower again. So we'll need to calculate average speed to figure out the speed that is average in your movement. Now I'm recognizing this word average from math. Do you remember calculating for average or mean? It's kind of similar to that, where we're taking some distance and we're doing some division to figure out the average speed. Now have a think moment. What is the difference between speed and average speed? Now if you're thinking that average speed measures a speed that isn't always consistent, you would be right. How is average speed calculated? Before we go into my definitions here, let's go ahead and take a look at this video.
What is speed? Speed is a quantity that refers to how fast an object is moving. An object with a high speed covers a relatively large distance in a short amount of time. Contrast to this, an object that has a low speed covers a relatively small amount of distance in the same amount of time. Speed can be thought of as the rate at which an object covers a distance. The average speed is defined as distance traveled over time of travel. To give you an example, meet Tim. Let's say Tim is walking down a sidewalk at 3:15 in the afternoon. 20 seconds later, Tim has traveled 35 feet. At what average speed was he traveling? To find out, we divide 35 feet over 20 seconds, and we find out that he was traveling at 1.75 feet per second. Day by day, we constantly see objects and speed within the world that surrounds us. So, are you ready to calculate speed?
Alrighty friends, so as you might have caught in that video, speed can be calculated by dividing the distance an object travels by the time it takes to cover the distance. So our equation for average speed down here says average speed equals total distance over or divided by total time. Now you might see this abbreviated where average speed will just be an S and total distance will be represented by a D and total time will be represented by just the letter T. Okay, now looking here, now remember we're on page 10, we're going to take a look at our example. Actually, go ahead and close that textbook because I don't want you to see the answers just yet because I think you'll get this. Now our example problem, and you might need some paper to help write this down. Our example problem says, a penguin swimming underwater goes 20 meters in 8 seconds. What is its average speed? So we're probably going to need our equation for average speed, but we'll also want to take a look at a few more things. So here are our steps. First step says draw and label a sketch. So we're going to want to create a sketch of what's going on here. We'll come back to that in a minute. Our next step will be write the formula, which we know our formula for average speed. Third step will be substitute into the formula. Now that means to take the information we know are givens from this problem and go ahead and insert that into the formula that we also know. And our fourth step is to calculate, simplify, and check our units. Now our units are really important here. Units are the way that we're measuring things. So for example, we're measuring our distance in meters, which can be represented by just the letter M, and we're measuring our time in seconds here, which can be represented by the letter S. Now let's head back to step 1. Draw and label a sketch. Here's how your sketch could look. As you can see, it's a line that's representing our straight distance here, and on the top I put the distance of the line, and on the bottom I'm writing the total amount of time it took to travel that distance. So we have 20 meters, just like it says in our example problem, and 8 seconds, also from our example problem. Now for writing the formula, all I'm doing here is just writing my formula for average speed, which is Speed equals distance over time. Now, just like we spoke about on the last slide, I wrote my abbreviated version with the letters that represent each part. Now I'm going to substitute my givens from the problem into this formula. So it will look like this. I have speed because, well, we're calculating for average speed. We don't know that yet. I'm replacing my distance with 20 meters, since that's what it says here, and my time with 8 seconds, since it says that here. So now I have speed equals 20 meters over 8 seconds. Now, because we have kind of a fraction here, we're going to need to divide. So you can type into your calculator 20 divided by 8. Go ahead and type that in. And this is the answer you should get. Speed equals 2.5 meters per second. Now, friends, we're not putting this right into our answer because first we need to check our units. We have to make sure they're right. Now, as you see here, we have meters over seconds, which is exactly why I have meters per second here. We don't want to suddenly have inches or hours or anything else. We need to make sure our units line up so that we could find the correct average speed just as it's written in our problem here. Now that I have that checked, I'm going to go ahead and write my official answer as 2.5 meters per second. Okay, friends, let's head into our lab. So to explain what we're going to do, you're going to watch this video on your own and complete the lab on your own too, but I'll just go ahead and explain it for you all. Now, we are going to watch a video of me in motion. This is actually me, so I hope you find it funny because boy, was it my workout for the day. Now, in this video, I will be traveling different distances at varying speeds, So your job is going to be to write down the distance, which is included in the video before each different way of traveling, and write down the time. Now, you might have to pause the video between each way of moving and really look for that time where it stops and round up to the nearest second. So remember, if a number is above 5 after your decimal, you round up a second, and if it's below 5, you round down a second. For example, if a time is 14.6, you round up to 15, but if a time is 14.3, you round down to 14. And you're going ahead and chart that on a little table I've set up on your worksheet, which I'll show you in a second. Now, the other thing you have to do is use the formula for average speed, which is right here and on your worksheet, and a calculator to solve for the average speed of each clip. Let's take a look at what this worksheet looks like before I send you off to do it on your own. Alright, friends, here's what your worksheet looks like. Make sure you write your name and the date. You can print this or you can do it on a separate piece of paper. Just make sure that when you're done, you take a picture of it and you send it with well-lit and not blurry photos onto the Google Classroom so we can give you a grade and make sure we're all up to date. Now, our procedure is kind of like what we said in the slides there, but I'll read it again. You need to watch each clip and enter the distance and time into the chart. Round the time to the nearest second. Number 2. Enter data into the formula for average speed, being sure to include your units. In this case, all of your units will be meters and second. Here's your formula for average speed again. Now, number 3, we have calculate the average speed and round to the nearest hundredth. Remember, that's the second mark after a decimal. So it will look 00.0, and then we'll have in bold number 4 because this is in my hundredths place, okay? Now, step number 4 is to write the answer being sure to include units, which are, like I said, meters per second. So go ahead and look down here and you'll go back to that video that I'll make sure to attach to this Google Classroom assignment, and you want to jot down the distance, which is set in the video, and the time, which you'll see in a stopwatch in the video, rounded to the nearest second. Now, once you have that, set up your formula, substitute in your numbers, go ahead and use your calculator to solve, and round to the nearest hundredth. They're going to need to do that for 8 different rounds of a whole bunch of different methods of motion. Now, for a bonus question, order the methods of movement from fastest to slowest using the average speeds you calculated. Alrighty, my friends, thank you for listening. Have a lot of fun with the lab. I can't wait to see you all soon. Have a great day. Goodbye.